Alright, so the focus of today, like I talked about yesterday, is we're going to take a look at prime factorization. But before we do that, we need to talk about what is a prime number and what is a composite number. And a prime number is a whole number that has exactly two unique factors. So meaning that it can only be multiplied by 1 and the number. Those are two unique factors. They're different numbers that are being multiplied together to give you a number. We're going to go over a list of numbers that are prime, a small list of numbers that are prime, and a small list that are composite, knowing that the list does continue, but just kind of the most common ones that you guys will see. So we'll take a look more about prime numbers here in just a little bit. Composite number is a whole number that has more than two factors. So for example, I'll use the number 10. 10, you can get it by multiplying 1 times 10 or 2 times 5. There are more than two numbers that multiply to give us 10, so that's why it's considered to be composite. Our next vocab word is prime factorization. So prime factorization basically is when we take a composite number and it's expressed as a product of just the prime factors. We use this for multiple reasons. This year, your focus is going to be just how do I write the prime factorization? Because as you move through 8th grade and high school, you're going to be using the prime factorization a lot more to do some more advanced problems. So right now, we're just working on the basics on how do we find the prime factorization. So again, we're taking a composite number and breaking it down into the prime, the prime factors of it. Now, how we do this is we do this by doing something called a factor tree. And a factor tree is a way to find the prime factorization of a number. There are multiple ways that you can do the prime factorization. In my opinion, the most effective way to make sure you're not missing any is to use the factor tree. And this is probably what you guys are familiar with and have done before. The one thing that's new this year is we're going to be studying monomials and doing the prime factorization for monomials. And we're going to do more work with monomials tomorrow. But a monomial is a number, a variable, or a product of numbers and or variables. So if we take a look at the examples down here, these are examples of monomials. 80 is just a number. So you guys have been actually working with monomials ever since you learned how to count. Those are considered to be monomials. When we're just looking at a variable, that's considered to be a monomial. Or when we have a number times a variable, that's also a monomial. The ones that are not monomials is when you have addition or subtraction in them. As soon as we have addition or subtraction, it's no longer considered to be a monomial. It's actually called something different. And again, you'll learn about that next year and into high school. But these are not monomials, so we are not going to be studying those today at all. And in this chapter, we're only going to be focusing on the monomials. So now we're going to take a look at numbers that are prime and numbers that are composite. We're going to start counting, and we're going to put them in the correct category as we go through. So we should start with 0. 0 is technically neither prime nor composite, so we're not even going to worry about it, okay? Because it's not going to be a factor of any of our numbers. So then we start with 1. Last year when I taught this, I know there was some confusion over whether 1 was prime or composite. 1 is technically considered to be composite because the only numbers that multiply to 1 are 1 times 1. And those are two of the same number, so they're not unique. So that's why it's technically not considered to be prime. So let's go to 2. So 2 is considered to be prime because the only numbers that multiply to it are 1 and 2. Same thing with 3. The only numbers that multiply are 1 and 3. 4 is composite because you have 1 times 4 and 2 times 2. So you have more than two numbers that give you an answer of 4. Keep going. 5 is prime. All even numbers, except for 2, are considered to be composite. So 6. 7 is also prime. 8 is composite. 9 is composite. 10 is composite. 11 is prime. 12 is composite. 13 is also prime. 14 is composite. 15 is composite. 16 is composite. 17 is prime. 18 is composite. 19 is prime. And last but not least, I'm going to stop at 20, but 20 is composite. And again, I'm going to put dots here on both of these lists. This list goes on forever and ever. Even as we get into the millions, they can still find a prime number in there. I'm trying to remember, I just read something as far as like I wouldn't say they found, but they realized another number was considered to be prime. So it does, more importantly, like I just want you guys to know the list doesn't just stop because we stopped at 20. It does keep going. There are more numbers that are composite, obviously, that you know, and you'll find that there are more numbers that are prime. Okay? But these are going to be the ones that you're going to want to think about, especially those prime numbers, as we practice our prime factorization. So let's take a look at first, just determining whether numbers are prime or whether they're composite. So let's take a look at 15. 15, if we look back at our list, we said this one was composite. And again, it's composite because there's multiple numbers that multiply to 15. 23. If you look on your multiplication chart, you probably don't find the number 23 on there because our multiplication chart isn't big enough. But that's also an indicator that it's probably prime. And it really is, because there are no numbers that multiply to 23 besides 1 and itself. Example C, even number, with the exception of just 2, that's always composite. 37. Again, if you don't see it on your multiplication chart, it's probably prime. Most of the time, you'll see the examples that I'm going to give you, you're going to find that that one is prime. E, even number, that is automatically composite. 31, there are no other numbers that multiply to 31 besides 1 and itself, so it is prime. All right, let's take a look at how do we find a factor tree, or how do we make one. Now, there are multiple ways on how to do a factor tree as far as how you go through these steps, but these are just the generic steps on what you would do. So the first thing is you're going to write the number that you are factoring at the top. So we're going to start at the very top, work our way down, so kind of think like a tree. It's really small at the top, and then it gets big at the bottom. Then you're going to choose any pair of whole number factors of the number. So you're just going to find two numbers that multiply to your number. Whether they're prime or composite does not matter, because we're going to then continue in step 3 to factor any number that's not prime. And we're going to keep going until all of the ends are considered to be prime numbers. And then last but not least, we'll write that prime factorization of the number. So let's take a look at our example for 20. So I'm going to start with 20 at the top. Again, I'm going to show this one way and how I see students do it most often. There is another way to do this one as well. I kind of show that at the bottom. We will come up with the exact same answer at the end. I want you guys to think about two numbers that multiply to 20. The answer I get most often on this one is 2 and 10. In this first example, or in our first one here, is 2 prime? Hopefully you're saying it sure is. Because it's prime, I'm going to circle it or I'm going to highlight it because that I know is going to be one of my parts of my prime factorization. Unfortunately, 10 is not prime, it's composite, so I'm going to break that apart even more. So 10 breaks down into 2 times 5. And then if I take a look at those numbers, 2 is prime, 5 is prime. So all the ends of my tree are all now prime numbers. So when we write our answer, I'm going to say, typically we should start with the smallest factor. So I'm going to start with 2. And 2 is written 2 times, so I'm going to have 2 squared times the 5. And this is the prime factorization of 20. Now again, let me just show you another way you could have done this as well. If you start with 20, you may have said, hey, 4 and 5 multiply to 20. 5 is prime, but 4 is not, so you break it apart. So notice that you would come up with the exact same answer no matter which way you did it. If you broke it apart this way to start with, or if you broke it apart this way to start. As long as you know your math facts, you're going to come up with the exact same way, exact same answer, no matter which way you wrote it. Now, one quick thing. In your homework, it's going to ask you to write the prime factorization. So if you just do the trees, I'm going to mark it wrong. My expectation is that you write the prime factorization like this. All right, let's take a look at a couple examples here. I'm going to start with 90. Again, there are multiple ways to do this one. Most often, I will see students break this one apart initially into 9 times 10. But unfortunately, those two are not prime numbers. So I'm going to think of two numbers that multiply to 9, which are 3 and 3, which just so happen to be prime numbers. Good. Now let's move to 10. Sadly, 10 is not prime, so I'm going to think of two numbers that multiply to 10. So I'm thinking of 2 and 5, which are also prime numbers as well. The end of everything here is a prime number, so I'm going to write my prime factorization. Again, I should write the smallest factor first, so I have 2, which is only written once, and if you want, you can put that little 1 there, that's fine, times 3, which is written twice, and then times 5, which again is written once. And you can put that exponent of 1 there if you would choose to do so. You don't have to. You could also write it this way. And that would be technically correct as well. If you guys have questions on that one, help each other out. And then when you're ready, move on to 24. 24 breaks down into, again, multiple ways to do this one. I usually see people looking at 4 times 6, which gives you 24. Not prime, but 4 can be broken down into 2 and 2, which are prime. 6 breaks down into 2 and 3, which are also prime as well. The ends of my trees are all, the end of my tree, I should say, are all prime numbers. So my prime factorization is 2 to the power of 3, because 2 is written 3 times, times 3. If you guys have questions, help each other out on that one. Otherwise, I would like you guys to try C and D. Go ahead and do these two for me. Press pause. When you're ready to go on, go ahead and press play and see if we agree with answers on this one. Again, my work might be a little bit different than yours, so all we're looking for at the end is to make sure the prime factorization is correct. All right, on 56, again, multiple ways you can do it, but no matter what, you should end up with 2 to the power of 3 times 7 for your prime factorization. On example D, again, multiple ways you can do this one. Make sure you're doing these without a calculator. So try to think about numbers that are easy to find or that you would know. And you're going to end up with 2 squared times 5 times 7 for your prime factorization. Again, as long as all your math correct, every single time you'll come up with this for an answer for 140. If you guys have questions, help each other out with these. So hopefully those last examples were a review for you guys and that you had done those before. The new part are these last couple examples that we're going to take a look at. We're going to take a look at how do we do a prime factorization for a monomial. So we have a number and we have letters. Technically we've been doing monomials, but these are the types of monomials you haven't seen before. So let's first take a look at 11, or I should say 11x to the 4y. Now, what we would do for the number is we would do a prime factorization for it. But what do you notice about 11? Hopefully you're noticing 11 is already prime. So because of that, I don't have to do a tree. I'm just going to say my prime factorization is 11. And then just like what we did yesterday, I'm going to write out what x to the 4 means and what y means. So I'm going to say x times x times x times x. 4 times to represent x to the 4. And then the y is just written once with no exponent. So here is my prime factorization of 11x to the 4y. So all you're doing with your monomials is you're writing out what those letters mean along with your prime factorization. So let's take a look at example F. Hopefully on example F you're noticing, my number is negative and I have letters. So let's take a look at first, how do I do a prime factorization for a negative 28? Anytime that you have a negative number, your first number in your tree is going to be a negative 1 and the number. This helps us to address that negative piece with it. A lot of you guys might be thinking, but Mrs. Haugen, negative 1's not prime. You're right. But we're going to still use it because this is the only way that we can get a negative in our prime factorization that we're going to write. So anytime it's a negative, make sure you get negative 1 and the number for your very first step. Then break 28 apart into 4 and 7. Or however else you see it. There's another way to do this one. So let's see here. I should have highlighted the negative 1 and the 7 because those are prime. 4 is not. So I'll break that apart into 2 and 2, which are prime as well. So writing out the prime factorization, I'm going to start out with negative 1 times 2 squared times 7. Then to write the x squared, I'm going to say a times a, and the b to the power of 3 is b, written 3 times. And you can choose to put dots in between those letters. You don't have to, it's totally your choice. But here's the prime factorization for that monomial. If you guys have questions, see if you guys can help each other out to see if you can figure out these 2 questions. When you're ready, I would like you guys to try the next 2 problems on your own. So if you guys try these 2, or the prime factorizations for them, I'm going to write them. So if you guys can pause the video and then press play when you guys are ready and take a look to see if we agree on an answer. All right, on example G, first factoring 12, and you should end up with 2 squared times 3. And then again, don't forget for the letters, you actually write out how many there are. So c squared, you're writing out 2 of them. D to the power 4, you're writing out 4 of them. So in example G, your answer should look like this. Again, no matter which way you do this, you're going to come up with this for an answer. Likewise on H, writing out the prime factorization. For your factor tree, this might be a little bit different. This first step should be the same, but everything after that could be a little bit different, but you'll come up with the same answer. Negative 1 times 2 times 3 squared times m times n, 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 n. So make sure you write out all of those ends. If you guys have questions, help each other out. And then when you're ready, you guys have the rest of the time to work on this homework assignment from page 488. Again, make sure you guys are doing this without a calculator. Obviously, I don't know if you're really not using a calculator on it, but know that when we take the quiz next week, which is tentatively scheduled for Wednesday, that you won't be able to use a calculator on it. So make sure you're practicing it like how you take the quiz, okay? If you have any questions, I will be back during prime time today and can help you guys out during that time if needed. Otherwise, I will see you tomorrow.